Good morning, my wonderful students. How are you all? Hope you enjoyed the last video. Well, welcome back again. Now we'll continue with the concept of relative motion. You can understand that sometimes when you enter a bus, you notice that if another bus passes the one that you are in, at a point it seems as if the both buses are not moving, but later on you understand that there is movement. Also, sometimes you look out through the window of a bus and notice that the trees or buildings are fast moving. These are just some of the examples of relative motion. So we say that relative motion is the motion of a body from one place to another with reference to another body, which might be stationary or already moving. Let me take it again. Relative motion is the motion of a body from one place to another with respect to another body that is already at rest or in motion. You can equally say that relative motion is the change in position of a body with respect to another body, which is either stationary or moving. Now, we're going to look into the terms used to describe motion of a body. There are some terms that we have to consider whenever a body is moving. One of the terms is the distance and displacement. Another term that we'll look into is speed and velocity of the body. Another one is acceleration, and then the last one is deceleration. Now, for distance, we say that distance is the length of path covered by a moving body. It is measured in meters. It is a scalar quantity. But displacement, on the other hand, is the shortest distance between 2 points. You can also say that displacement is the distance in a specified direction. It is equally measured in meters. It is a vector quantity, unlike distance. The next one will have speed and velocity. For speed, we say that speed is the rate of change of distance with time. The speed is the rate of change of distance with time. It is measured in meters per second. Then velocity, on the other hand, is speed in a specified direction. You can also say that velocity is the rate of change of displacement with time. It is equally measured in meters per second, just like that of speed. They have the same units. Now, in speed and velocity, we have what we call constant speed, or we can call it uniform speed. We also have what we call average speed. Now, when you talk about constant speed or uniform speed, we say that it is when a body covers equal distances in equal time intervals. No matter how small the time interval may be, we call it a uniform or constant speed. Velocity, on the other hand, will have constant velocity and or uniform velocity. The constant velocity or uniform velocity is when equal displacements are covered in equal time intervals. No matter how small the time interval may be, we call it uniform or constant velocity. Then the next one is acceleration. We say that acceleration is the rate of change of velocity with time. Acceleration is defined as the rate of change of velocity with time. It is measured in meters per second squared. Also, for acceleration, we have constant acceleration. Constant acceleration or uniform acceleration is when a body covers equal velocities and equal time interval, however small the time interval may be. Then the next one is deceleration. Deceleration is the rate of change of displacement with time, but in this case it is known as negative acceleration. This change is when a car at a very high speed or a body at a very high speed comes to rest within a given time interval. Such movement or such motion is termed deceleration. So constant deceleration is when the acceleration of a body reduces in equal time intervals, no matter how small the time interval may be. At this point, we'll come to the end of the class. We'll see you in the next video.